Look at the clock. Is there a 1 on the clock? What's the chance of that? Let's find out. This is an example of a question, number 19, on an AMC10 type of test. What fraction of the time does a 12-hour digital clock display the digit 1? A digital clock shows the time like this. A digital clock might say 1:29. Or the digital clock might say something like 9:36. But the digital clock will not say 10:72. That's not a time. So now the question is, in a clock like this, what fraction of the time is there a 1? Before we calculate it, what do you think? Is it big? Is it small? What does big even mean? The answer will surprise you. To do this kind of question, it is actually probably the easiest to think about this by saying how the 1 can appear. You see, with a clock, hours and minutes are very different. In the hours side, we are allowed to have numbers which go from 1 to 12. But in the minutes side, our numbers go from 0 to 59. And those are different. The 0 to 59 is different from the 1 to 12. So it's easier to think of them in two different parts. Let's actually make a Venn diagram which is counting the number of minutes for which this is true out of a 12-hour cycle. What I'll draw here is two parts. And the first part is that there's a 1 in the hour. And the other one is that there's a 1 in the minute. Now, I have these two different kinds of things to count. Let's start first with 1 in the hour. Actually, I'm going to fill out this Venn diagram in a way which you'll see is not necessarily the way we always do it, but I'll show how you can do it in all those different ways anyway. The 1 in the hour is the easiest, because the hours that have the 1 in them are 1, 10, 11, and 12. 4 hours out of a 12-hour cycle. So this entire part here has 4 times 60, 240 minutes. Okay. Now, if I want to know how often 1 appears as a minute, let's actually see what it is in each of those hours, because it repeats again every hour. One of the easiest ways that I like to do this is to say which minutes have a 1 in them. 0, 1. 1, 1. Oh, actually there's also 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. 21, 31, 41, 51. I draw it in this way because you can see that there are 6 this way. That makes sense because there are 60 minutes. 6 this way, and 10 that way. But there's 1 that's double counted in the middle. So there are 6 plus 10 minus 1 equals 15 times that 1 appears in each hour. I'm showing this because whenever you do this kind of question about how many times does a digit appear in some sequence of 2-digit numbers, you always will see a cross pattern like this. Actually, you, after a while, can even do it in your head and say it should be 6 plus 10 minus 1, 15. Okay, and if there are 15 times that 1 appears in each hour, now I can finish this off. Actually, it's going to be easy for me already to even see what this part of the Venn diagram is, because I know that I will have 15 times in each hour, times I already took care of 4 of the hours here, so there are 8 hours left over here. I could do this by the usual inclusion-exclusion method too, which I'll maybe make a comment about too. But this 15 times 8 is 30 times 4, which is 120. And when you add them both together, you find that there are 360 times altogether, divided by how many minutes are there in 12 hours, which is 12 hours times 60 minutes in each hour. Let's now cancel some common factors. Actually, I see 60 times 6 will go here. 6 over 12 is 1/2. Actually, that's pretty high. If you look at the clock, half the time, there's a 1. Sort of. you usually aren't awake at equal probability at all hours of the day. For example, I will make a guess that you are probably asleep every day at 4 o'clock a.m. So it's not exactly true that there's a 50% chance. However, what this means is that if you looked at the clock at a random time through the day, it is a half chance. Now I want to talk about this in two other ways quickly. One of the ways is, the usual way you do this kind of question is that you actually work out this side, and the middle. And that's going to give you the same answer, because if I worked out the entire right side, I already know it's 15. So if it's 15 per hour, this whole right side is 15 times 12 hours, and the ones in the middle are just 15 times those 4 hours in the middle. And of course, 15 times 12 minus 15 times 4 is 15 times 8. But I want to show you at the end another shortcut on this, which is actually how I did the problem when I first saw it. What I said is that I saw this calculation first because I thought this was the harder one. And to me, 15 is special when an hour has 60 minutes. What I said is, oh, this is very interesting. This means that the fraction of times that 1 appears in each hour is 1/4. That's the chance that 1 appears in the hour. If I know this, now what I can say is that for 4 hours of the day, which is 1 o'clock, the 1 o'clocks, the 10 o'clocks, the 11 o'clocks, and the 12 o'clocks, there is a 1 probability of a 1. For the other 8 hours of the day, there is a 1/4 probability of a 1. But the relationship between 4 and 8 is that 4 is 1/3 of the day, and 8 is 2/3 of the day. So what this means is that 1/3 of the day, I will see a 1 for sure. And for 2/3 of the day, I will see a 1 with 1/4 chance. And so when you multiply these together, you get 1/3 plus 1/6, which is 1/2. And there's another way of seeing the 1/2, where you don't even have to use large fractions at all. Essentially using the fact that because of the 15 minutes that it is in an hour, that you got a nice 1/4 just from there. At the end of the day, I think perhaps the most interesting takeaway from this is the fact that there is this 1/2 chance of seeing a 1 on your clock.